Hello, sixth graders. Today we're comparing and ordering fractions, which means we have to find a common denominator. We have to make sure these fractions look the same. And then we're going to do the big Pac-Man or the alligator thing. We're either greater than, less than, or equal to. First one, we have 4/5 or 2/5. Which one is bigger? What's really awesome about this problem is they already have the same denominator. So you can easily compare. We have to make sure that the bottoms of the fractions, denominators, are the same. Once there, you just look at the numerators. Which one's bigger? The 4 or the 2? We want to eat more. I'm always hungry. Kids are mostly hungry all the time too. So we want to eat Pac-Man style, the 4/5. Let's move on to the next problem. You're like, that's super easy, Mr. Green. Now we have 3/8 and we have 1/3. This is where it gets a little trickier. Okay, we're going to be changing these things, and this is what I call it with kids. We have to stack fractions, and this is why I call it like this. So we're going to do 3/8 equals, and we have 1/3 equals. This is how I stack fractions. I'm going to use this term several times, and I want you to get used to this practice. Unless you have something that's incredibly better, I want you to stack fractions. This is what we have to find out. What number does 8 and 3 both go into? The smallest number, preferably. They don't both go into 8. If I were to multiply those two numbers together, I'd get the number 24. So let's make 24 our common denominator. If we can't find one that they both go into that's smaller, let's just multiply the two together. This is what we do next. We do 8 times 3 is 24. So 3 times 3 is 9/24. So that means this 3/8, this new fraction that it equals, is 9/24. This bottom one, we have 3 times 8 is 24. 1 times 8 is 8/24. So 1/3 is 8/24. The next thing I asked, do they both have the same denominators? They sure do. Which numerator is bigger? The 9 is bigger. So that means 3/8 is bigger than 1/3. Let's move on. We have 3/4 and we have 17/20. We need to make sure that the 4 and the 20 both go into something. Now, we're going to stack the fractions just like we just did on the last problem. So we have 3/4 equals. We have 17/20 equals. And this is where you have to be careful. I could easily make 80 my common denominator because 4 times 20 is 80. But I'm going to ask myself this question. Can 4 go into 20? It can. So let's make 20 my denominator. That is a horrible 2. Let's make 20 my denominator. If 20 is my denominator, watch down here at the bottom. 20 times 1 is 20. 1 times 1, or 17 times 1 is 17. So this can stay the same. On the bottom, we're going to go 4 times 5 is 20. 3 times 5 is 15. So this fraction equals 15/20. So what's bigger? 17/20 is bigger than 3/4 because 3/4 equivalent fraction is 15/20. 17 is bigger than 15. Let's move on. The same concept works here. We have 19/20. Is it greater than, less than, or equal to 99/100? I'm going to stack the fractions because that's what I always do. 99/100. What number does 20 and 100 both go into? Now, I know they both can go into, if I multiply them, I know they can both go into 2,000, but let's not do that. Can 20 go into 100? It sure can. So let's make 100 my denominator. This automatically stays at 99/100. I'm not going to mess with that. But 20 times 5 is 100. So what is 19 times 5? Let's work that off here to the side, just in case you don't know their 19 facts, which I don't. 9 times 5 is 45. 5 times 1 is 5, plus 4 is 95. So this fraction of 19/20 equals 95/100. So what's bigger, 99 or 95? 99 is larger. Let's keep cruising along here. I really like this next problem. It says 4/7 and 4/10. Now they don't have common denominators, so I could easily stack these fractions to find out what the common denominator is with 70, right? And then I could work out the problems. Times 10 times 10. This equals 40/70. This equals 28/70. So this is 40/70, and this is 28/70. I could easily have done that, or much easier, if I take a look there, this denominator right here means there's essentially, if we're thinking about a pie or a pizza, that means there's this 4/7 means there is 7 pieces to that pie. This one right here means there's 10 pieces to that same size pie. Now, if you're hungry, would you rather have 4 big pieces out of a 7-piece pie or 4 small pieces out of a 10-piece pie? The 4 bigger pieces would be more food. Does that make sense? Hopefully that makes sense a little bit, because there's less pieces. The pieces, I should say, that the pies are the same, but you're getting 4 bigger ones because there's only 7 instead of 4 smaller ones out of 10. Okay? I confuse my own kids when there's the same size pizza, and if I cut it up into like 15 slices, they think there's so much food. That's because I'm working with 3-year-olds and 4-year-olds at home, and you kids are 11, 12, or 13. Okay, let's move on. We have 2/3 and 7/9. Let's stack these fractions up. We got 2/3. We got 7/9. 3 and 9, they both go into 9. You can keep this one the same. 3 times 3 is 9. 2 times 3 is 6. What's bigger? So this is 6/9. I always rewrite it just to make sure it's not too messy. 6 or 9, what is bigger? The 6 or 7, I apologize. The 7's bigger. So 7/9 is bigger than 2/3. Next one, circle each fraction that is less than half. Okay, 3/6, is that less than half? I don't know why I just threw a 1 there. That equals half, right? So we're not going to circle that. 6/10, is that less than half? Well, what's half of 10? 5 is, so that's more. 1/3, what's half of the 3? It's 1.5. So 1/3 is actually less than half. 5 is our denominator. What's half of 5? 2.5 is half of 5. So it's 2 less than 2.5. It is. 11. What is half of 11? It's 5.5, right? So 6/11 less than half? It isn't. 25. What's half of 25? 12.5. Is 12 25ths half or less than half? It is. You see how I solved that? So look here. What's half of 6? It's 3. So is 3/6 less than half? No, it is half. Let's move on. Here's my favorite problem of the day today. It says write the fractions in order from smallest to largest. Now, which one of these, when I'm looking at it, because I could stack all these things up and find a common denominator, and it would take me like a year to do. I don't feel like doing that. I value my time. It's precious. So how would I solve this? Well, let's take a look here. Is there anything that is given away for the absolute biggest or the smallest? Looking at all these fractions, which fraction looks like it is the smallest? This one stands out to me, 1/12. We have a 1/3 and we have a 1/5 as well. But this means there's 12 pieces to that pie and there's only one of it. So 1/12 is my smallest for sure. I'm going to cross that one off. Now I have one less one to worry about. Is there anything up here that stands out to be my biggest? Right here, 49 of 50 is my biggest. That means you're having 49 of a 50-piece pie. The very next one, though, gets a little trickier. So where does 15/16 fall? 15/16 is my next biggest. I'm going to move this right here. How about my next biggest? It looks like I'm dealing with the 7/14 and 6/10. I have 7/14 and 6/10. Just like that last problem, so this equals, what's half of 14? It's 7. What's half of 10? It's 5. So this is more than half, so 6/10 is my next biggest. Then I have 7/14 as my next. So now these are done. Here's my next question to ask. I'm down to 3 fractions left. This is how you problem solve, kids. Keep watching. I have 1/3, I have 1/5, and I have 2/5. Well, I know 2/5 is bigger than 1/5, but where does 1/3 fall? So this is what I'm going to do. I'm going to stack these last 3 up just to make sure I don't make any mistakes. What number does 5 and 3 both go into? They both go into the number 15. You're probably like, Mr. Green, this is taking forever. If you take your time, you'll be fine. 5 times 3 times 3, we have 3/15. Times times 3 times 3, we have 6/15. Times 5 times 5, we have 5/15. Do you see why I solved this? So if you take a look here, 6 is the biggest. That means my 2/5 is here. 5 is bigger than 3, so I have 1/3 here. And 3/15 is left, so 1/5 is it. That is how you solve smallest to largest. Take your time, pick out the ones that are the giveaways that are much easier, then you make the problem that much simpler. Now we got some practice problems. Now I'm not actually going to solve these things due to time, but I'm going to show you how to stack up the decimals. First of all, 13 is bigger than 4, so I'm going to write this out like this. This is where kids tend to still struggle. And then I have to put, I'm going to change the color for the missing numbers. A 0 here, a 0 here, and I am subtracting. That's how you would write that out. I am lining the decimals up, and your answer, your decimals right there. I've noticed that when I write it out for you, it makes sense. A lot of kids, when you see this problem here, you put the 2.068 on top. That is not right. Put 5.9 on top, 2.068 on the bottom, and you are subtracting. But you need to put zeros in these places, because if you don't, a lot of you are writing down an 8 and a 6 right here. That's not correct, because you're going to have to borrow and make this a 10, and this would be a 2. You have to borrow and you make this, you have to borrow from here and make this a 9, or an 8, and you're going to make this a 9, so this becomes a 3. So keep that in mind when you're solving these problems, okay? I actually want you to solve these, because I'll be checking these with you, okay? Here's the next one. 0.9 minus 0.077. Zeros here, decimal right there. That's how you line those up. This last one's a good one. We have 8. Remember, there's a hidden decimal right there. 3.643. Subtract. You see how that'd be an easy problem for kids getting correct? Let's solve this one. Make this a 10. I have to borrow. This would be a 10, but I have to borrow, make this a 9. I have to borrow from here, make this a 9. I have to borrow all the way from here. So when I'm subtracting, I get a 7. I get a 5. I get a, so 10 minus 3 is 7. 9 minus 4 is 5. 9 minus 6 is 3. 7 minus 3 is 4. 4.357 is my answer. Move the decimals straight down. Go ahead and continue to do those properly. You have to line up the decimals. And only when you're multiplying, you don't have to line up decimals. You just count, okay? When you're adding, subtracting, even when you're dividing, it's move the decimal straight up. Hopefully this helped. I look forward to working with you with some fractions today. Good luck.